We have a MacBook Pro. It's a refreshed version of the A1707, which is 2016-2017. However, this is a 2019 machine. Apple only had one of this in 2019, and it was discontinued and then replaced with a 2020. A 2020 version of it has the power button distinctively separated from the touch bar as well as the escape key. So the non-touch bar obviously has no touch bar, and that was 2018 and 2016, 2017. In 2018, they didn't have any. The non-touch bar was not refreshed. In 2019, it was refreshed with this one, which is 82159. Just gonna confirm that. Yeah, so it's 82159. That is the touch bar version of the non-touch bar. Everything looks pretty much similar in terms of, you see, you have two ports, same two ports. Everything looks very similar, although the screens are not interchangeable. You can use a screen for testing purposes. The trackpads are interchangeable. You can use the trackpad of the non-touch bars on this one, and it's going to work 100%. The batteries are interchangeable. And yeah, the touch bars are the charging ports on this ones are removable, while the non-touch bars are soldered directly to the board. Okay, so this is coming in for no power, and it's quite urgent. The the owner of the device catching a flight tomorrow, so needs to be completed today. So first thing we do before we connect power to the device, we want to be able to identify exactly what state the device is in. Also, this is coming from a repair company, so they have done pre-assessment on the device. Okay, I'm not sure why the screen assembly cowlings are missing. I suppose this was a new screen at some point. Okay, so I don't know if that's a concern in terms of, although that has nothing to do primarily with the device not switching on, that wouldn't have anything to do with it. But I'm just curious. I guess at some point the original screen was replaced. Uh, okay. So let's see. It doesn't seem like the device it's liquid damage. We don't see any signs to suggest that it is liquid. So what we are going to do for this one, the primarily known issue on this one's this guy here. So on this one's the primary issue. Now the board view it's 820-01598. The common issue with this machine it's this guy here, U7710, and should be two of it on the board, and U8110. That's one of the commonest issue on this board. So you want to you obviously usually you will find a short on a 5-volt line, which is going to be caused by you removing U7710 as well as U8110. Usually one of it sometimes, and sometimes you have to replace both. Now, those are sitting on the CPU line. So sometimes you get a short there, you address the issue, short is gone, but the device is not going to post, or you still get the device not turning on. So I hope this is not the case, and I hope we're not having to deal with a case of a CPU issue. So Okay, that is that. Let's disconnect the battery cable. Battery cable is disconnected. We are going to make a basic measurement. Not that we're expecting anything, but then let's see what is it that we have on our PP bus line. PP bus is going to be on this. We can get PP bus line on this fuse here. So we have our black probe on ground, our multimeter is set to continuity, and then our red probe. Let's see what we have. We don't have a short. Let's say do you have a short on the SSD line? No, we don't. Okay, so let's see that. Okay, so right away we do not see we don't see anything. So what I'm going to do, just to be sure that we're not having issue with U7710, so before I plug power to it, I'm going to take the board out because I don't want to diminish my chance of getting the device fixed. Say if it turns out that the issue is U7710, I don't want to somehow send power uh, to a section of my CPU in whatever form. So what I'm going to do before I even put power to the board, I'm going to take the board out to see if I have a problem with U7710 or the other one, which is a U88 U8810. Let's see, yeah, U8110. Okay, so before because I've not been able to figure out exactly why is it that when they fail and you replace them, the short is gone, but you don't the device itself does not work in terms of it either doesn't post or it just doesn't start. So I'm just I'm hoping that that wouldn't have to be that it's affected the CPU. So whatever we can do to minimize that, I think it would be best to do so. So we are not going to send power to it until we can confirm exactly what is it that we are dealing with. If this is the first time you're doing this, you want to be sure that you're taking note of your screws. Okay, pull this out. So what I'm gonna do is so this is a chip that I was referring to, this guy here. So 1 and 2. So these are some of the common issue we would get on this board. So I'm going to check to see if I have a short here and here, which is a 5 volt line. Okay, we don't have a short there. And then this one. Okay, that's good. We don't have a short there either. Okay, let's go over the boards to see if anything stands out. Board looks fairly clean. Nothing stands out. Okay, nothing stands out. So we are going to connect power to it now. See what is it? What state the board is in. Okay. Let's see what is it that we have on PP bus. That will give us an idea what we have on PPDC in. Let's see what do you have on PP bus. Let's try that again. Let's see what do we have on PP bus. PP bus is 0 0.8, which would suggest that we have 5 volt on PPDC in. And we have already confirmed that we don't have a short on PP bus, so it's so it will mean we have 5 volt on PPDC in. Let's see, it's 0 volt, and then on the other side, okay, we have 20 volt, and PP bus. Okay, now we have 12.3. Okay. 12.3 on PP bus. Okay. But then we have 20 volt on PPDC in. Okay. We have any SO rail present? Okay, we don't have any SO rail present. 12.3. We have PPDC in. Okay. PPDC in is 20 volt. Okay, that's fine. And then let's check the other port. So one of the port we are getting nothing. Okay, so let's see if it's an issue with the charging port. Let's get another one. Still nothing. Okay, and the other side, nothing. Okay. Okay, so one of the CD3217, so one of the CD3217 is not responding. Okay, let's come here. So one of the ways you can easily correspond your ports to your CD3217 to your controller, it's by checking what you have on this line here. So usually we use the fuse, correct? But then the fuse is going to be secondary. Primarily, when you see when I click on this, for example, on this line here, PP20 volt underscore USB-C X bus V bus, yeah. Now that will give you the corresponding. So what I'm trying to say is, if I plug my charger to this port, the question is this port corresponding to this one, or is it corresponding to this one? So one of the ways I can confirm if this port is corresponding to this is if I connect power to this, I will check to see what do I have on this line here, PP20 volt underscore USB-C XB underscore V bus. Now, if I get voltage here, it means that I'm on the channel of U3200. If I get voltage, then on this one here, the same thing. I'm going to check here. So on this one as well, if I get voltage on this line here, that will tell me that I am on the channel of U3100. So that is important sometimes when you're trying to figure out which is which. For example, now we have 20 volt on one, because the way this will work is the fuse that we are using. if we get, so let me show you something. So on this, on the second port, I suppose we're getting 20 volt on the second port, correct? So I'm just gonna, so that information they can use across all CD3217, all CD32 controller repair, whether it's 15 or 17. So you see on the second port, let's see, I think we're getting 20 volt on the second port. Okay, now you see we're getting 20 volt on the second port, correct? Now you see that we have 20 volt on this fuse, and then on the other fuse, we also have 20 volt. Now you ask yourself, okay, so if I have 20 volt on both, does it mean that they are both okay? But if I transfer this to the other, we get 0 volt across. So yeah, 0 across. And then on the other side, we have what? We also have 0. Now the question then will then be, okay, then so which of the port is not working? So one of the ways you can figure out which that port is corresponding to is by checking. So if on the other side, because um, I, I know that this port here, so let me show you this. So if I click on that now, so I have the first port connected. Now I'm going to check what do I have on this line. So I can either use this or that. Okay, this is a diode. That's diode. Can use that capacitor there. So let's see that capacitor, which is this one here. So we have 0. Now, if we go to the other side, which is this one here, the other side, let's go back to the, so if we go to the other side and click on the same line, we can use this capacitor here, correct? Which is this one here. We can use this capacitor here. So let's check that. We have 0. Now, if we flip, if we now bring, remember, we are, so we can easily connect this to this, correct? Okay, not yet. We because we measured voltage here, 0, voltage on the other line, it is 0. Now, the one that we have voltage on, it's the one that will now differentiate between which is which now. So let's check again on that line to see if we have anything. 0.49. Okay, then on the other side, the same 20 volt. Now that tells you that this port corresponds with this one. Do you understand? So this is this, and that one is that. Now that you see how with this one we can measure. This is unique to the port. We can measure this voltage, yes, but the fuse will not be unique to the port. The fuse we read on both sides. You see the fuse we read on both sides, which will confuse you to ask, to then ask yourself, okay, which one? But this line here would not confuse you, because you clearly see 0.49. That tells you that the voltage is not coming from here, but the other side. Okay, so we know that we have an issue with this one. So first thing we want to do is we want to try sort this out. So the reason why we although we could move on to find out why the device is not starting, because even though we have 20 volt on the second port, we do not have, the device is not starting, it's not moving, it's not going transitioning into SO state. So we have that port connected, and so I'm just gonna see. So we have that, and we have 20 volt. Yeah, but then the fuse on our PVOS, we're getting 12.3. So I'm just gonna get a working board. So, So on a working board, you see what we're getting on our PP bus. So we're getting 12 is not 12.3. So 12.6 is good. That is almost a booting voltage. So if we go to, let's see, on our SO now, on our SO rail, that's a 2.5 volt rail for your SSD that is present. Unlike this one, even though we're getting 20 volts, so two things that are standing out. So yes, one, we see that one of the CD3217 is not working. We are getting 20 volt from the one that is working, but we're getting 12.3, which will tell you that the device is basically not boosting as yet. And if we check one of the SO rail, which is the SSD 2.5 volt rail, we're getting 0 volt. So the first, so we can, there are two things we can do. We can continue to find out why the device itself is not going into SO state, or we can sort out the CD3217 first. Do you understand? Before having to move forward. So if we sort that out and it's still, if we sort that out and we're getting 20 volts there and it still doesn't start, then we cannot find out why it doesn't start. But for now, let's sort out the CD3217 as to why it doesn't start. So we are going to replace that CD3217. Uh, and the reason why we are going to do so is this. So the same working conditions that is required for one port is what is required for the other port. Now, what I'm trying to say is the reason why we are just going ahead to replace this CD3217 is because we have 20 volt on the other side. If we didn't have 20 volt on the other side, we are not going to replace the CD32, or we are not going to worry about the CD3217 region. We are going to worry about the working conditions of both, considering both now. Now, so what we are going to do now is we are first of all going to see if we have a short on this particular line. Remember, on this line we were getting completely 0 volt, correct? So we are on the other side of the board. So we are going to click on this line here to see if we have a short. So we can use C3201 to see if we have a short on that line. So let's check that. So before we even replace the chip, let's see if we have a short on that line. Because remember the CD3215 or the CD32s, they have multiple regions, and they fail in different forms. So yes, you can have a CD3215 or 17 that fails, but it will have the basic voltage, which is a 5 volt in. In this case, we have 0 volt. Yeah. So because of that, we are going to check on this line to see if we have, as we know, that is going to be on the main line to and from the charging ports to your CD32. So we want to check on that line to see if we have a short on it. And we don't. Just to confirm, so this is the board that we are working on. Did you take my marker here? I've been struggling to find it. What? Yeah. Oh, after that. Yeah. Okay. So let's see. We don't seem to have a short. Let's see. Okay, we don't have a short there. This, this. Okay, so we don't seem to have a short on that line. So what we are going to do is we're just going to go ahead and replace it, and then I see what happens afterwards. Get another one. I'll give it a bit of time to cool off. So there are different ways to do this. So one of the ways that I try, so the first way I do it is you remove the chip and try to maintain exactly the way it was in its previous destination, in its previous position upon to in order for you to replicate that in the next destination. So by doing so, I am not going to rebuild the chip itself. Neither will I try to do anything to the solder pad on the destination. So that is like it's the easier way to do it. But then in order to do so, you have to make sure you maintain the state of the solder balls on the chip itself as well as the solder balls on the destination. That is one way. The other way is to just remove it and then reball the chip itself and also remove the old solder from the old from the new destination of the chip. That takes a bit more time. I do not usually reball my CD32s. I reball them manually. So if I take them out, for example, and it doesn't, I don't have the solder balls the way I want them, then I will have to manually reball them. So, and but then the first option that I described, one of the disadvantage of it is if you don't get it correctly, what happens is you have the solder balls underneath it, um, basically crumbling, which then creates a short. So so that's just one of the disadvantage. But the advantage, it is quick. You just transfer from one position into another position. So usually when I take this option, what I do is I first of all check to make sure that I don't have a short. before I connect power to it. And then if you also take that option, so one of the things you want to avoid is you want to avoid you interfering with the chip in terms of once you start to apply hot air, do not try not to interfere with the chip, because by doing so, chances of you breaching the boards underneath it will be very high. It works perfectly fine if the chip flows in place by itself. Okay, we don't seem to have a short on it. Let's see if we have, let's see if it works. Okay, that's good. We didn't have that before. So what I'm doing is I also don't want to give myself unnecessary heart attack. So I don't start by checking to see if I have what I was missing. I just check to see if I have something similar. So because 20 volt would be that the chip was properly installed. So I just tell myself it's not properly installed, but then I check around it, which is to see if I have my PP3 V3 underscore RTC. Now this will not be present if I don't have PPDC in. Do you understand? So that's what I'm basically doing. So I'm going to see if I have voltage on PP on RTC, see if I have voltage on 1.5, and then see if I have 3.3. So let's see, we did confirm that we have voltage there, which is good. The 1.5, that's good. And the 3.3, that's good. Now we can check our PPDC in. Let's see what you have on PPDC in. This guy here. Now we have 20 volt. Okay, so that's good. Now let's see what we have on PP bus. PP bus is now 12.6. Let's see, do we have a 2.5 volt line? That's beautiful. We have a 2.5 volt line. So you see now, so now, which means our board is starting, and which means our problem was the CD3217. So two things that I needed us to understand here. So we didn't have, one of the port was giving us 0 volt completely. In other circumstances, that port itself, the CD3217 will not prevent the device from going into SO state, from transitioning into SO state. You just have a port that is not working. Mind you, the CD3215 or 17s, they have different regions inside of them, depending on the failure of depending on the type of failure that the CD3217 or 15 it's having. That will determine what role it will play. Because say for example, give an example of the seed an A1990 board, where you have, okay, A2141 or A1990, where you have the C9081, the capacitor that fails. The capacitor itself, when is the fact that the capacitor is on the board, basically the fact that it's on the board proves or causes creates a problem on the board. The capacitor not being on the board will cause the board to work. So just by removing the capacitor, for example, and then the board works. With this one, for example, we have two CD32s. One will get in 20 volt. The other one we get 0 volt. In an ideal situation, we would say, okay, fine, we have 20 volt, that should work. And then we only have one port that is not working. But in this case, we have 20 volt, but the other one we're getting 0 volt. We could have decided to continue from there to find out why the device is not starting. But first, before we do that, we needed to make sure we restore what is apparent to us, which is one of the CD3217 is not outputting, or there's no communication at all. So we first of all address that. If after addressing that we get 20 volt on it and we still do not have, the device state is not able to go into SO state or transition into SO state, then we can now find out what is it that is preventing the device from starting. So I'm just going to quickly clean the board, and we are going to test it. So it's the steps that you take in your troubleshooting. It's very important because that way you will avoid many mistakes. When you go out, you get better. When you get time, look for my marker. If you don't find it, then when you go to the shop, you can get a permanent marker. Actually, coming tomorrow again. Oh, those people, destroyers. He doesn't listen. Okay. So let's just confirm that the charging port itself, that's also something to sort something important to check. So sometimes it might be that the problem originated from the charging port. So you want to check before you connect power to it again. Okay, charging port looks okay. So we are only going to connect the cables that we need for testing. Just have one speaker connected. That was strange. I thought what's happening? Oh, okay. So we had a chime, and that's it. It's a working device. Okay, so that's about it, guys. I will see you guys in the next one.